Okay, for this example, I've given you a much more difficult exponential to try to graph on your own. So I've given you sort of all the pieces that you need to deal with here. So I need you to make a table and graph it. And while you're doing that, we're going to find x, y-intercept, domain and range, and our asymptote. So take a moment, pause the video, see if you could do this on your own. And like I said, it's much harder than our previous one. So hopefully you paused and tried it on your own. And now coming back, first thing you want to do is make a table. And the table, easy enough as long as we're doing it with our calculator, right? So table, I'm going to go ahead and edit my function. I need 5 times 2 to the x power minus 1. The nice thing is as long as this matches, and if I really was paranoid, I could even go ahead and change this so it looks exactly like the function that I was given. There's no way I can make a mistake because the graphing calculator knows exactly what to do, or the calculator knows exactly what to do, even if I might make some mistakes. So I'm going to start this at 0 and calculate. Now, I'm going to go ahead and do this table also by hand, just in case Isaac happens to watch the video. I know he doesn't have a calculator. So we probably want to choose numbers from like -3 up to 3. It's a good place to start. Unlike our parabolas, we don't have that worry about like, where is the vertex? I need to make sure I have it both sides of the parabola. I really just need to go kind of a little bit beyond 0 and a little bit before 0, just sort of see what's happening. See which way this thing is growing exponentially and where it's tapering off to in terms of an asymptote. So if I wanted to do this by hand, I would need to type in 5 times 2 to the -3 minus 1. So I would not do that by hand in terms of the math. I would type that into a calculator. 5 times 2 to the, and this is where, let me just turn off my math type for a second. Or maybe I should grab a crappy calculator just so I can show what it would look like if I were in Isaac's position. Sorry, I should have been prepared. But instead, I'm running around my office looking for a calculator. All right, got one. So this is the calculator Isaac has. So if I was doing this using his calculator, I would type in 5 times 2 to the, and I need to make sure that it knows that it's a -3. Thankfully, the negative symbol will make that clear, minus 1. So apparently this is negative 0.375. And from my other calculator, I could go here and press the squiggle button. It tells me the same thing. And then squiggle button, 0.25. And I keep going. It's 1.5. And if I didn't know that, I could press the squiggle button. Then we've got 4 and 9 and 19. And at this point, I could probably stop writing down things in my table. All right, so let's go ahead and make our graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we need to go over 2 and over 3. Okay, so 0, we're at 4. Immediately next, we're already at 9. And then we have a 19 if we really wanted to put it on there. On the other side, -1 is at 1.5. Then I got 0.25. And then, lo and behold, I just crossed my axes, unlike before, and now I'm at -0.375. And I might want to investigate that side a little bit more. And you can see what's happening is it looks like we're getting closer and closer to a -1. So what's happening is we've taken our graph, our original graph, and we've shifted it down so that now our asymptote is here at -1. And that makes sense if you think about this equation. 5 times 2 to the x minus 1. Well, we know the original asymptote for this piece of it was at 0. So if this is 0, 5 times 0 is 0 minus 1. The new asymptote is at -1. That -1 means we shifted everything down one value. So that's where we're going to get into trouble. We can never actually solve that equation. But this shift down, which is why I said this question is a lot harder than other questions, it gives us an x-intercept, which we didn't have before. If we wanted to find the x-intercept for this, we'd say 0 is equal to 5 times 2 to the x minus 1. And this equation we can actually solve. We can add 1 to both sides. 1 is equal to 5, 2 to the x. We know from the worksheets today that we have to isolate the exponential piece, so we have to divide by the 5. Right? That's why we're doing this, is all to get this piece here alone. Okay, so now we have 0.2 is equal to 2 to the x. And now is when we would rewrite this using that bar bra thing we talked about. So log base 2 of 0.2 is equal to x. So we'll go in here and say, okay, well, log base 2 of 0.2, that tells me that this thing crosses, and we can kind of see it over here, at negative 2.32. Yeah, that's about where my drawing is. So my x-intercept is negative 2.32 comma 0-ish, right? And if I wanted to double check that, I could even plug back in to my original equation, 2.32, oops, negative, minus 1, and we get out something that's very close to 0. So that's our x-intercept, right? Our y-intercept, well, we can see that right on our table, right on our graph. So that is 0 comma 4. No reason to do any math there. Domain, this is just like when we dealt with our polynomials, our quadratics. There's nothing that we're going to get in trouble for plugging in here. But our range will have some issues. Since our asymptote moved down to negative 1, our range is going to start at negative 1 and go up to infinity. But again, we can never truly reach negative 1. So like I said, this was a very tough question. I'm going to give you guys one more to try as an example that'll be more similar to what you'd see on a test.